Identify the role of H to the power plus in the chemical equation. Locate the hydrogen ions in the balanced chemical equation. 5H2O2 plus 2MnO4 to the power negative plus 6H to the power plus gives 2 millinewtons to the power 2 plus 8H2O plus 5O2 because H to the power plus is on the reactant side of the equation. These ions must be consumed as the titration proceeds. Relate consumption to ion concentration. As the reaction proceeds forward, H to the power plus ions are continuously used up to produce water. Consequently, the concentration of hydrogen ions, H to the power plus, in the Erlenmeyer flask steadily decreases. Understand the relationship between acidity and pH. Acidity is determined by the concentration of free hydrogen ions. A lower concentration of H to the power plus means the solution is less acidic. Mathematically, pH is defined as pH equals log H to the power plus. Because of the negative sign in the logarithmic definition, a decrease in the concentration of H to the power plus causes the pH to increase. Formulate the final conclusion. As H to the power plus ions are consumed, the solution becomes less acidic and the pH increases. This corresponds to option C. The correct answer is option C. As H plus ions are consumed, the solution becomes less acidic and the pH increases.